All right, welcome. Today, we're diving into something that sounds like it's straight out of science fiction, but it's getting closer and closer to reality. We're talking about a quantum native database, and we're going to break down how this could completely flip the script on how we find information, maybe forever.
So let's start with this classic problem. How do you find one needle in a haystack made of a trillion pieces of straw? This isn't just a fun little saying anymore. It is the central challenge of our digital world. Our data is growing like crazy, and our ability to find the one right thing we need, well, it's getting nearly impossible with the tools we have today.
You see, our current computers have a really simple but really slow strategy. They just check every single piece of straw, one after another. Now, when you're dealing with trillions of pieces of data, that one-by-one method just doesn't cut it. We are slamming right into a fundamental speed limit. And that brings us to what we can call the data search dilemma. It's this growing gap between the super complex questions we need to ask and the insane amount of time it takes for our classical computers to even find an answer. This is the exact moment where quantum computing steps onto the stage.
To really wrap your head around this, imagine this for a second. You have to find one specific sentence, but to find it, you have to read every single book in an entire library, page by page, word by word. That's exactly what a linear scan feels like for a computer searching a huge database. It's just exhausting and so inefficient.
So how in the world do we break through that wall? Well, the answer isn't just a faster computer. It's a completely different way of thinking about computing. It means we have to start thinking in superposition.
Okay, so at the heart of this whole new world is the qubit. A classical bit, it's like a light switch. It's either on or it's off. Simple. But a qubit is more like a spinning coin. While it's spinning, it's not heads and it's not tails. It's kind of in a state of being both at the same time. And this incredible property is what we call superposition.
And the difference here is just profound. A classical bet holds one piece of information at a time. A qubit, because of superposition, can hold and process countless possibilities all at once. It's not just a simple upgrade, it's a whole new language for information.
This leads to a really fascinating outcome. A classical database gives you one solid, definite answer. Here it is. But a quantum database, it gives you something totally different, a wave of probabilities. It doesn't exactly hand you the answer. Instead, it points you with extremely high certainty to the most likely answer. So how does a quantum computer actually use all this probability stuff to find our needle? Come on, let's peek inside the quantum engine that makes this incredible search possible. It all runs on a process called Grover's algorithm, and honestly, it's pretty ingenious. First, you load the whole database into superposition, so every single possibility exists at once. Then, this special function called an oracle goes in and essentially tags the right answer. You can think of it like making the needle vibrate at a totally unique frequency. And finally, the amplification step, it's like putting on noise-canceling headphones. It boosts the signal of that one vibrating needle while hushing all the noise from the straw, making the right answer pop right out when you measure it.
And the result of all this? A completely mind-blowing speed-up. A classical search takes n steps, where n is just the number of items. A quantum search, though, takes roughly the square root of n steps. For that trillion-item database we talked about, that's the difference between a trillion operations and just 1 million. It's a total game changer.
But you knew there was a but, right? Of course there's a catch. This incredible power comes with its own set of very unique challenges. This isn't magic, it's physics. And that means we have to balance this amazing potential for speed against the reality of a very noisy environment.
So here's the core challenge. Quantum states are unbelievably fragile. The tiniest little disturbance, what scientists call noise, can completely mess up the calculation. So a quantum database can't just go full throttle for maximum speed all the time. It needs a really smart optimizer to constantly balance that speed against the risk of errors.
The solution, for now, is a hybrid approach, all managed by this incredibly smart optimizer. For every single query, it analyzes the quantum path and asks some really important questions. Okay, how fast is this going to be? What's the real probability of an error? And maybe most importantly, is this actually going to be any better than just using a good old classical computer for this specific task? It's all about dynamically picking the right tool for the job at the right time. To put it really simply, a classical optimizer is just looking for the cheapest, most efficient path from A to B. A quantum optimizer, on the other hand, is more like a master strategist. It's constantly managing this complex trade-off between raw speed, the risk of noise, and the overall probability of success. It's a completely different way of thinking. So where is all of this headed? Well, the researchers behind this idea have laid out a really clear three-stage roadmap that shows us how we get from where we are today to a truly quantum-native future.
Right now, we're in stage 1, what you could call the quantum-assisted era. This is where quantum computers are like these highly specialized assistants, tackling the really tough search problems that get handed off from classical systems. This is the stuff happening in labs today. The next step is quantum-centric, a true hybrid where data just flows seamlessly between classical and quantum memory. That's when businesses might really start to see the first real-world uses. But the final destination, the end game, is stage 3, a quantum-native world, powered by fault-tolerant hardware, where all our data can live and be processed entirely inside the quantum computer. That's the dream.
And that just leaves us with one last really fascinating question to think about. When finding the needle in any haystack, whether it's discovering new drugs, modeling our climate, or understanding financial markets, becomes almost instantaneous, what currently impossible problems will we finally be able to solve?
All right, so there's a new AI model on the block called UniWeTok, and it might just be a massive breakthrough in how AI learns to both see and create. For a long, long time, those two skills have kind of been at odds with each other, but this new approach, well, it could finally bring them together. Let's dive in. Just take a look at this image. It's incredible, right? An AI can generate stuff like this pretty easily these days. But here's the billion-dollar question. Can the same AI that creates this image also fundamentally understand what it is? For the most part, the answer has been a big nope. You'd get a model that was a great artist or one that was a great analyst, but never both. This new research basically asks, why can't we have both? Okay, so here's how we're going to break this down. First, we'll get into the core problem, what I'm calling AI's three-way challenge. Then we'll look at why the old tech just couldn't keep up, before we introduce the star of the show, UniWeTok, and its secret sauce. After that, we'll check out the test results, and then wrap up by talking about what this all means for the future of AI. So, if you want to build an AI that's truly multimodal, one that's totally fluent in both the language of images and the language of text, researchers have been stuck in this constant tug of war. It's this tricky balancing act between three different goals that just don't want to play nicely together. And here they are. Number 1, high-fidelity reconstruction. Can the AI look at an image and recreate it perfectly, pixel for pixel? Number 2, complex semantic extraction. Can it go beyond just seeing a bird and understand the concept of a phoenix made of fire? And number 3, generative suitability. Can it then take all that knowledge and create something totally new and amazing? Getting an AI to do all three of these things well at the same time, yeah, that's been the holy grail. Now, before we see how UniWeTok pulls off this magic trick, we gotta understand the key piece of tech that's been the big roadblock for so long. It's a little something called a visual tokenizer. Think of it like this. An AI doesn't see a picture the way you and I do. It needs a translator. A visual tokenizer is that translator. It takes an image and breaks it down into a bunch of little visual words or tokens, a language the AI can actually read. And of course, the better that translation is, the smarter the AI can be about the image. And that's exactly where the problem was. The old tokenizers were specialists. If you wanted that perfect pixel-for-pixel reconstruction, the visual words it created were too literal, just too noisy for the AI to get the big picture. But if you wanted it to understand the deep meaning, it had to simplify everything, throwing out all the fine-grained details you need to actually generate a new image. You were always making a trade-off, and you always lost something important in the translation. The dream was to have a tokenizer that didn't compromise. And that brings us to UniWeTok. Researchers from ByteDance and a handful of top universities got together to build this thing, a unified tokenizer designed from the ground up to finally solve that three-way challenge. The key word here is unified. It's everything. The whole point of UniWeTok is to build a bridge right over that gap we were just talking about. It creates a single visual language that's detailed enough for perfect reconstruction, meaningful enough for deep understanding, and clean enough for amazing generation, all at once. Okay, so how on earth does it actually do it? Let's pop the hood and take a look at the secret sauce, because this is where it gets really, really cool. It all starts with a number that is just mind-bogglingly big. 2 to the power of 128. That is the size of UniWeTok's visual dictionary. It's an astronomically huge number of visual words it can choose from. This massive vocabulary is the first piece of the puzzle because it lets the AI describe an image with an almost limitless level of detail and nuance. But, a giant dictionary is useless if you don't know what the words mean. That's where a few other innovations come in. First, they use a clever training technique that specifically teaches the model to pick visual words that are packed with deep meaning. Second, they have another trick that makes sure those words are also perfectly structured for creating new images. And finally, some real technical wizardry under the hood makes it all work together in harmony, preventing those different goals from fighting each other. So that all sounds great in theory, but here's the real question. Does it actually work? Well, the researchers put it through its paces, and honestly, the results kind of speak for themselves. And yeah, the numbers are impressive. On the standard tests for generating images, it's hitting state-of-the-art levels, beating out the previous top models. And for things like image editing, it's right up there with the best of them. The key thing here is that it's not a one-trick pony. It excels across the board, which really proves that whole unified idea. But here's the real kicker. It achieved all of this while using way, way less training data. We're talking 33 billion training tokens for UniWeTok versus a competitor that used 262 billion. That is a huge difference. This shows it's not just about throwing more data at the problem. It's about a fundamentally smarter, more efficient design. And that smarter design unlocks some absolutely incredible creative power. I mean, the proof is in the pudding, right? Look at how it masters these really diverse artistic styles, like this beautiful, subtle ink wash painting. Or check this out. This is a perfect example of its advanced spatial reasoning. You've got the pyramids, the desert, the camel, all contained logically inside a glass bottle, which is itself floating on the ocean. The AI has to understand so many different layers of context to make a concept like this actually work. And the detail? Wow. Just look at the sheer fidelity here. The glowing embers, the intense light from the fire, the texture of every single feather on this phoenix. This is that high-fidelity seeing ability being put to work to create something that's both incredibly complex and crystal clear. And the range is just fantastic. On one hand, you've got this epic, mythical dragon guarding its hoard of treasure. On the other, a totally serene snow leopard in front of a glowing ice castle under the northern lights. It can clearly jump between totally different vibes and concepts without breaking a sweat. So, okay, we're getting some seriously amazing pictures. But beyond that, what does this all really mean? Let's zoom out and talk about why a technology like this actually matters in the big picture. Here's the core takeaway. By finally truly unifying the ability to see, understand, and create, UniWeTok isn't just another incremental update. It's a blueprint for the entire next generation of AI. We're moving away from a world of specialized, single-task AIs and toward a more holistic intelligence that can interact with the world in a much more fluid and human-like way. So what does that actually let us do? Well, imagine editing a photo just by talking to it. Literally just saying, make the sky look like a sunset. Or what if you could take a picture of your living room, show it to an AI, and say, hey, generate a few new decorating ideas for me, but in a rustic farmhouse style. This is the foundation for a whole new class of creative, interactive AI tools. This really just blows the doors wide open for what's possible. For the first time, we have a clear path toward a single AI model that can have a real visual conversation with us, one that can see what we see, understand what we mean, and create what we imagine. And it leaves us with one very, very exciting question. Now that we can actually do this, what are we going to build next?
You know, Apple is famous for being super secretive, but it looks like the walls of Cupertino are starting to crack. Reports are flooding in that the tech giant is making a massive, and some might say pretty desperate push into the world of AI. And get this, it all comes down to what you wear.
Look, for a while now, Apple's kind of been seen as lagging behind in the AI race. Falling behind rivals like Google and OpenAI. But now, these bombshell reports from The Information and Bloomberg are hinting that a secret plan is in motion to completely change all of that. So the question is, what exactly is it?
Well, according to these inside sources, the answer can be boiled down to just one powerful number: 3. Yep, 3. That's how many new AI-powered wearables Apple is reportedly fast-tracking. And we're not just talking about one little gadget here. We're talking about a whole new ecosystem of devices, all designed to work together to put Apple right back on top. Okay, so what is this secret AI trio? And more importantly, why the sudden rush? Well, it's pretty clear Apple is feeling the heat. With every single new breakthrough from its competitors, the pressure just keeps mounting on Cupertino to deliver something truly innovative.
And I want to be clear, these aren't just, minor updates to products you already own. No, we are talking about a totally new category of devices for Apple, from AI-powered pens to smart glasses, and a major overhaul of the AirPods. So, let's break them down.
And what's really striking here is just how ambitious this is. I mean, you've got 3 totally different kinds of devices, and each one has its own special role. So first up, you've got this AI pen, a tiny little device with cameras that you can wear on your clothes. Then there are the smart glasses we've been hearing whispers about for ages, which could be a total game changer for augmented reality. And finally, a totally supercharged version of the AirPods, basically turning them into a computer for your ears.
All right, let's dive into this AI pin first. Try to picture this. A device so tiny you'd barely even notice it, but it's constantly seeing the world just like you do. Yeah, the cameras are the real key here, gathering this constant stream of visual info that can be used to give you real-time help with anything from identifying objects to translating languages on the fly.
Okay, but the smart glasses, now that could be Apple's biggest gamble yet. I mean, they're jumping into a market that's already seen some huge successes and some really big flops. The stakes are just incredibly high.
So internally, the project has a code name, N50, and it's been in the works for a while, but now it's apparently being pushed right to the front of the line. We're talking teams being reassigned, deadlines getting moved up. This is a massive sign of just how seriously Apple is taking the competition. And yeah, this slide really lays out the battlefield. You've got Meta, who's already a huge player with their Ray-Ban glasses. Then there's Snap. They've been playing around with specs for years now. And then you've got Apple, aiming for a 2027 release. So yeah, they're kind of late to the party, which means they have to show up with something that's truly revolutionary.
And this is where it gets really, really interesting. According to Bloomberg, Apple is trying to start production as early as this December. I mean, that is an unbelievably aggressive timeline for a brand new product category. It just screams urgency inside the company. The end goal? Get these into our hands by 2027.
So the big question is, how is Apple going to stand out? Well, the plan, from what these reports are saying, is to go more upscale and feature-rich. And come on, this is classic Apple, right? This is their signature move. They waltz into a market, they define what premium means, and they slap a high price tag on it. It's a strategy that's worked for them time and time again.
But here's the thing, these devices aren't meant to be standalone gadgets. No, the real magic, the real innovation, is how they're all going to work together. This is where we really start to see Apple's vision for the future of personal computing really start to take shape.
So the whole experience is supposed to be completely seamless, super intuitive. Your wearables, so the pen, the glasses, the AirPods, they're constantly just capturing information about what's around you. Then they feed all that data back to your iPhone, which is like the central brain. And right at the heart of the whole thing is a new supercharged Siri using all that context to give you really smart, proactive help. And this right here is probably the most important thing to get about Apple's whole strategy. These new wearables, they're not here to replace your iPhone. They're designed to extend it, to make it even more essential. The iPhone is still the brain of the operation, and Siri is the ghost in the machine making it all happen.
So all of this just begs the question, right? Why the big rush? I mean, why is Apple, a company that's literally famous for taking its sweet time, suddenly in such a massive hurry? The answer? It's simple. They're in a race.
The driving force behind this whole thing is just pure, old-fashioned competition. Apple is watching its rivals make these huge leaps in AI, and they absolutely know they can't afford to get left in the dust. This isn't just about launching cool new products. This is about survival in a tech world that's changing faster than ever.
So as we're standing right on the edge of this new era of, ambient computing, it leaves us with a really deep and maybe even a kind of chilling question. As our gadgets get more and more woven into our lives, seeing everything we see, hearing everything we hear, are we actually ready for a world where there are no secrets? It's a huge question we're all going to have to answer for ourselves, and probably a lot sooner than we think.
Hey everyone, and welcome to The Explainer. The world of artificial intelligence is moving at, an absolutely insane speed. And today we're jumping right into a massive new update from one of the biggest names in the game, Anthropic.
I mean, it is just so hard to keep up, right? It feels like every single week there's a new model, a new breakthrough, or some new mind-blowing benchmark being announced. The pace, as the slide says, is just completely relentless. So in this incredibly crowded and fast-moving field, Anthropic has just made its next big play. They've rolled out a brand new model called Sonnet 4.6, and this is their answer to that constant, relentless push for more power and more capability.
Okay, so let's get into it. What exactly is Sonnet 4.6? Well, it's a huge update to Anthropic's really popular mid-sized AI model, the engine that powers a lot of their main services. And hey, this isn't some beta test or a far-off release. We're talking about a major upgrade that is already in the hands of tons of people. And this is the crucial part. If you use Claude, either on the free plan or the pro plan, guess what? You're already using Sonnet 4.6. It is the new default. That means all of its new tricks are available to you and me right now, not just locked away for big enterprise customers. So the big question is, what actually makes this new model better than the old one? Anthropic is really zeroing in on a few key areas where Sonnet 4.6 is supposed to be a major leap forward. So the company is really focusing on three main things here. First, it's supposed to be way better at writing and understanding code. Second, it's much sharper at following really complex instructions without getting confused. And third, and this is a really interesting one, it's got more advanced skills for actually using a computer, which, by the way, is a massive area of focus for the entire AI world right now. Okay, those are all fantastic improvements. But there's one showstopper, one headline feature that really, truly stands out from the rest. And it all comes down to how much information the model can remember at any given time. 1 million tokens. Now, to give you some context, a token is basically a piece of a word, and the context window, think of it as the AI's short-term memory. So at 1 million tokens, that memory is just gigantic. It's double what Sonnet had before, and honestly, it's a number that could completely change how we use these tools. But what does 1 million tokens actually mean for you and me? Well, Anthropic puts it like this. It's enough space to drop in an entire software codebase, or a super long legal contract, or even dozens of dense research papers, all in a single prompt. That is a ton of information to process at once. Big numbers sound cool for sure, but how does Sonnet 4.6 actually perform? How smart is it really? Let's take a look at how it stacks up against the competition when you put it through standardized AI tests. One of the most impressive stats they've released is this, a 60.4% score on a benchmark called ARC-AGI-2. Now, AGI stands for Artificial General Intelligence. That's kind of the holy grail of AI, creating models with human-like reasoning. This test is specifically built to measure those kinds of skills, which makes a score over 60% really strong. And this chart gives us a great visual of where Sonnet 4.6 fits into the grand scheme of things. You can see it's clearly outperforming most of the models in its weight class. Now, it's not quite at the level of the absolute top-tier models, like Anthropic's own powerhouse Opus, but for this more accessible, mid-tier category, it's a massive step up. All right, so let's zoom out for a second and look at the bigger picture here. A new model is always cool, but this release actually tells us a lot about what's happening in the entire AI industry right now. This timeline really says it all. I mean, look at this. Anthropic dropped its most powerful model, Opus, just 2 weeks ago. Now we have Sonnet, and we're expecting an update to their smallest model, Haiku, really soon. This points to a crazy fast 4-month update cycle, which just goes to show you the unbelievable pace of development across the entire field. So let's boil it all down. What do you really need to remember? First, if you're a Claude user, you just got a big, free upgrade right now. Second, that massive 1 million token context window is now available, and it's a huge new tool in your toolbox. And from a bird's eye view, this proves Anthropic is absolutely keeping up with its rivals, and that the insane speed of AI development is only getting faster. And all of this leaves us with one really fascinating question to chew on. We're seeing huge updates, not every year, but every few months. At this absolutely blistering pace, you just have to ask yourself, what's the next big barrier that's about to get smashed? What's the next breakthrough just around the corner?